So my name is Carl Zimmer, and I'm a science writer and semi-regular blogging head person. Mike, why don't you introduce yourself?
So I'm Mike Gazzaniga. I'm a professor of psychology and neuroscience at the University of California, Santa Barbara. And I have the job of directing the SAGE Center for the Study of Mind, and new duties also to run the MacArthur Foundation project on neuroscience and the law.
Yeah, one thing that I was really wanting to talk to you about today was this program with the Law and Neuroscience project that you started up. And it sounds really fascinating, and I guess as background, I should just mention that so Mike Gazzaniga is one of the founders of a whole area that's sometimes called cognitive neuroscience, of basically figuring out how the mind works, and that has led him into a lot of fascinating areas like trying to understand sort of the nature of the self and consciousness and these big ideas, and then also into issues of bioethics. And so this new project of yours, this Law and Neuroscience project, seems like a really fascinating kind of continuation of all that. So could you describe the project, what its goals are, how it got started, and what you guys are doing with it?
Well, it's been happening over a 2-year process here. The original idea came from Stanford professor Robert Sapolsky, who, on query from the MacArthur Foundation, said, the criminal justice system needs to be overhauled because of our increasing knowledge of brain mechanisms and the fact that we are largely deterministic, determined and automatic systems, and in that context, notions of retribution and punishment become difficult to understand. Yeah. And that very large swath then has to be examined very carefully. And so a group met for about 1.5 years, consisting of neuroscientists, of lawyers, of jurists, of philosophers, and we hammered out a proposal that in the end was looked favorably upon by the MacArthur Foundation, and we're now about a half year into this initial 3-year project trying to examine really large questions and focus in and see where neuroscience may or may not be important in the study of, and the practice of law and in our legal system. So it's a very big agenda, and there are lots of people. There's about almost 50 people involved, scientists and lawyers, as I said, throughout the country. So we're just getting going, and we have 3 networks. One of them deals basically with differing brains. Are you going to have a reason for exculpability if you have brain damage, that kind of thing? One of them deals with normal decision making gone wrong, and because after all, the prisons are full of people who just make bad calls and make bad decisions, and there's nothing really obviously wrong with them other than that. And then one of them deals with the tough problem of addiction. 50% of people in jail are addicted, and are they just hopelessly drawn to crime because they have to feed their addiction, and what do we do about that, and how do we think about that? So lots of people involved. Stephen Morris at the University of Pennsylvania, Hank Greeley at Stanford, Owen Jones are on the co-directors of the sessions, and Mark Rakel, really the head brain imaging guy in the country, Bob Desimone at MIT, Bob Knight out here in California, Scott Grafton, and so forth and so on. Lots of people involved, and the overall project is really kind of being overseen by Justice O'Connor and a governing board.
Sandra Day O'Connor?
Sandra Day O'Connor, mm-hmm. Yes. And So it's large in scope, and the chore will be to see how specific we can get and what kinds of things we can really do to increase and disambiguate areas of the law that involve neuroscience. Sorry, that's a long-winded answer, but that's kind of the painting.
Well, yeah, I mean, it's a big project. Well, what's if you could give an example? I mean, what's the matter with the law from a neuroscientist point of view? I mean, why do you need to fix it as a neuroscientist? What's the matter?
Well, there's a lot going on now where neuroscience really urges caution in using neuroscience data in the court. Lots of caution about the use and misuse of brain images. Lots of caution about the really veracity of so-called lie detection systems.
Yeah, well, let's talk about this a bit. I mean, so where do we stand with using brain imaging to detect lies? I mean, so the basic idea is that you, at least the last time I was reading about it, was that a person would be, I don't know, might be given an MRI, or maybe there would be some other way of monitoring their brain activity, and then they would say things, and judging from the brain activity, you'd be able to say whether they were telling the truth or not.
Yeah, that's the idea, and where that all sits now is that the probability that any particular study is accurately capturing the truthful state of somebody or not is not that high, and it certainly shouldn't be used in a court of law at this point. So the neuroscientists is at a point where they're saying, this could work. Mm-hmm. There could be a point where this sort of technology will really actually work, and you should be thinking about the implications of that for the law and personal privacy and all kinds of issues. So right now, their big point is that it's not ready for the courts, and while there's some enthusiasts for it out there, they do not reflect the predominant view amongst neuroscientists.
Well, it's interesting because this actually gets into a lot of these brain studies that come out and, frankly, get written up a lot by people like me, where because the equipment is so expensive and the process takes so long to scan people and to crunch all that data in their brains, you see these studies that come out, they're based on 10 or 20 people, and I mean, that's just not a big sample size, and yet, that's about as good as a lot of these studies can get at this point. But so when do you get? I mean, is there going to be a way to really do good quality control on brain imaging work to say, this is good enough for prime time, this is ready for the courts?
Oh, I have little doubt that down the road that these techniques will develop and there will be a sure-footed way to answer these questions. But it's you have to realize right now. Any particular brain image supposedly reflecting the mental state of somebody is a shot. It's a stroboscopic moment of their brain state, and it's hardly full of veracity with respect to their real mental state at that time. It just shouldn't be used yet. Mm-hmm. And it's not in when you think, as my colleague Scott Grafton says, when someone reads a hematocrit level, it's done by trained technicians, it's licensed by the state, it's reviewed every year, machines are standardized, and blah, 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 blah. It's a highly regulated thing. Here is just, somebody sticks their head in the scanner and they got a picture and they take it to the court and say, look at that, Where's the deal? And that's just a misuse of scientific knowledge at this point. And people who are in the business are fully aware of that and are a little bit embarrassed by the chutzpah, quite frankly, of some of those who want to use it.
Do brain images show up in court much these days, whether for lie detection or to show some reason that someone should be considered not guilty? I mean, how often are brain images getting into the courts these days?
Well, there's something, we did a Lexis search a little while back, one of our fellows, and something like 900 cases in the court system around now that refer to neuroscience, and a lot of that has to do with brain scans. I mean, you could take the classic Hinckley case. Ultimately, I think in the second or third try, they did allow the CT scan to show his dilated ventricles, and therefore giving reason for having insanity defense work in his case. So it's out there, and now there's studies that just came out very recently that such physical evidence has a powerful effect on the jury. And you just mentioned neuroscience and the brain and this or that, and people go, oh, okay, I guess that's the way it is.
Yeah.
And that's just not right, and it's not accurate, and it's premature, to say the least.
Yeah, it's interesting. I wonder if it has to do with these beautiful images that come out of these studies, or if it's just sort of how our culture is so focused on the brain. I mean, I saw a study not too long ago where what they were doing was they were sort of presenting people with research done either with neuroimaging or just kind of more kind of classic, psychology type experiments, and just judging people's behavior. And even if they were coming up with the same conclusion, somehow if it had to do with the brain and if there were images involved, people just felt that was much more real and authentic.
Yeah, it's a paper in the recent issue of Journal of Cognitive Neuroscience goes through this, and it's just another warning sign that we're at that phase in the interaction of this kind of scientific knowledge with the judicial system, and it's time to get out in front of it and be thinking about it, and that's really one of the aspects of this effort. I mean, something that's interesting that you mentioned talking about lie detection is about privacy. And I mean, I don't know how much this project is going to be dealing with that, but that is an interesting issue. We like to think of our thoughts as private, and I don't know if a polygraph is an invasion of privacy, but somehow letting someone seeing the firing pattern of your neurons does seem like a real violation. I mean, and this could become an issue not just for like lie detectors, but for if you want to get on a plane and maybe they set up some sort of brain scan at your security checkpoint or something like that. Are you dealing with that much with the project? Well, I think these things will come up and will be examined. The project, what it's doing is in the process of isolating questions and then focusing, developing working groups to focus on them and try to come out with a white paper or a statement about what we think we know about that. So one of the things is that this is early on in the project, and so I don't want to answer questions that we're supposedly investigating, because the real spirit of it is a lot of these things just really haven't been thought through. And so the chore in front of everybody here is to think very carefully about these things. And so, but yes, I think all those topics are highly relevant, and I'm sure will be brought into the mix.
So it was interesting. You mentioned about one of the topics you're going to be focusing on is these sort of minds gone wrong, just sort of these bad calls.
Yes.
Are you talking about kind of crimes of passion, or just when good people do bad things, or what are you talking about here?
Right. So why does someone do something that's self-destructive? Why are they making this bad moral choice? What is it? Because their emotional system is such that they simply don't appreciate the wrongness of it and feel that moral moment, or is it that the susceptibility to the payoff is so great that it overrides their judgmental system. Other decisions that come up are biases. The whole system, we believe in a bias-free court process. And everybody works hard to make sure that there's no biases in the jury and the judge and everybody. And yet there are ways that are emerging out of the behavioral sciences and even the neurosciences that suggest that you may claim you don't have a bias. You may say you don't have a bias. But we can sort of peek under that and find out you've got a hell of a bias.
So how do you do that? How does that?
Well, the classic way of doing it is in behavioral research is to do these priming experiments where you look for the speed with which somebody makes response to being primed by a word. So in the pure cognitive way, if I give you the word nurse and I tell you to judge it whether it's a word or not, you have a certain reaction time. And then if the next word is apple, you have a normal reaction time. But if the next word is doctor, you have a much quicker reaction time. That nurse brought up all of the associates of the other of the word nurse, and doctor is one of them, and so bingo, you can respond more quickly. Where you just take that basic idea, and you can see how it can be extended into emotional issues, into categorical issues of how you think about a person who did X, Y, or Z behavior, and so forth. So even though you say, we all know you're not supposed to have a prejudice, we all are well socially adapted to those things, but now you go and do these tests and you find out people have all kinds of biases.
Does that mean that like everybody has these biases, or is it that more people than you think would have the biases? I mean, what do these kind of studies show? Well,
some people are genuinely biased, and some of them are not, and so maybe you could use such tests. This is some people's thinking. It becomes a horrendously difficult thing to manage how you would do this. But essentially in jury selection, people are trying to pull out people that they recognize may possibly, through their conventional wisdom, be biased against their client. And that's the whole point, of course. So, but new studies coming out of Princeton by Susan Fisk and others in a brain imaging environment show how you may not have emotional reaction to a class of person. So if you take I think the example in one study was a drug addict, and compare your emotional response to seeing a drug addict versus someone who may be in a sorrowful or pitiful situation but not a drug addict. In the one case, you have a nice emotional reaction to them and an understandable emotional reaction, but when the drug addict comes up, you don't treat them any differently than if there was a block of wood. So if you're sitting there in the court, right, and you're the judge, this applies to the judge, applies to the jury, you're not really having your empathetic mechanisms work on that at that moment. And is that something to be concerned about?
So there are these. So are you talking about actually like studies that can actually look at some of these regions in the brain that are associated with empathy, and then see how they respond when people see different things?
Yeah, I mean, one could imagine that in the perfect world where you wanted the minds of the juror or the judge clean as the driven snow. That some horrendous screening process would go through. Well, that's obviously not going to happen.
Right.
But to be aware of where empirical work and state where there might be issues would be a contribution, and it remains to be seen whether that can be done.
It just seems like the law, I mean, almost in a sense, in order for the law to be the law, it's got to draw some really absolute distinctions. And I mean, one of these absolute distinctions is that you get a fair jury, and a jury that's not going to be biased. But of course, these rules were all set up before before modern neuroscience. So what happens when neuroscience says, those that you just can't draw that line? I mean, does it mean that you need to move the line a little bit, say, okay, we know that we can't have a perfectly unbiased jury, but we'll accept, we'll come up with a measurement for bias, and we'll say you can have it 10 points, but not 20 points. You know what I'm saying?
Absolutely. Here Robert Sapolsky likes to make the point that the people coming out of science recognize that almost every observation is on a continuum. There's no bingo. There's no honor. The cell doesn't stop or not stop. It gives a graded response, and everything has this distribution. And all of a sudden, you get to the law, and it's the guy's guilty or not guilty.
Right.
Well, what is that? And so, but having said that, of course, the law. Lawyers will tell you that the law is plays a very important role in dealing with what they call the gray area. What are the mitigating circumstances here? How do we think about this? So, I think you put your finger right on something, and I think it's something that has to be thought through. That maybe the law is actually pretty good at this, and they're more realistic than is your believing neuroscientist that because he's working on this thing and because he's coming up with these deterministic models that he says, wait, but it's much more complex than that, and so forth. So you're putting your finger. This is the excitement of the project, that it is getting people into the room and trying to get them to think beyond the representation of their own specialty, and that's it. And this interdisciplinary project, like all others, that requires patience, and then finally people, I think, come up with ideas that just weren't present at the beginning of the process, and I hope that's where we go.
I'm sort of curious about some of the developments that are going on in neuroscience that will. Maybe will illuminate these issues in the law. So, like decision making. So, obviously, decision making is a big issue in deciding if someone's guilty or something or not. As you say, you might make a bad decision. You might make a snap decision to do something that you later regret, that people would judge as wrong. How do we make decisions? How does that work?
Well, it's the $64 question, and the best neuroscientists are trying to get in and look at the neurophysiology of that, and a few of them are actually involved in the network. Bill Newsom at Stanford and so forth. It's in terms of the really basic underlying neurophysiology of a decision. But, here's the deal. I mean, the brain, what is the brain for? Right? It's a decision-making device. That's what it does all day long. By millions of them, by the second, and so forth. And when does it do them? So, if, I like to use the example, if you touch your nose with your thumb, or with your finger, you have the sensation that your nose and your finger are being touched simultaneously.
Yeah, I'm doing it right now. Okay.
Yeah, and yet, that neuron that's cueing you that your finger's been touched is about 3 feet long, and the neuron that's been cueing your nose is a little short guy, right? A couple inches long.
Right.
And it all gets integrated somewhere.
Right.
And then there's this, voila, there's a simultaneously being touched. That's probably all going on 250, 300 milliseconds before you're consciously aware of it. It's all getting added and computed and figured out. And then somehow you become phenomenally aware, consciously aware of it. So that almost says it, so by the time you're consciously aware of it, you've done it. The brain's already done its work. And how are you going to think about that in questions of action and then criminal action? Is there, as we understand these things, are you?
So we just had a little technical difficulty, but I think we're both back again. So, Mike, you were talking about how you how how we think about retribution when we're dealing with a brain that is basically making decisions all the time, even when we're not aware of it.
Right. But the point being that if these things are happening in a time zone prior to your being consciously aware, is your sense that you're consciously aware of them just an illusion, and therefore you should come to grips with the fact that we're determined systems, and if we're determined systems, then why should you blame anybody? What's the point of blame? Now, I don't buy that, by the way, but, because I think responsibility isn't in the brain, it's in the rules of the social group. And what do we do in life is we learn a bunch of rules, we become educated about which rules are good to follow, which ones are bad to follow. And so when people speak and are concerned about free will, I think the question is, free from what? You know, when I finally make a decision, or my brain makes a decision to do something, I want the decision carried out with accuracy and determinism. I don't want to be decided to put my foot over here and then see my foot go over in another place. So the point is, you have to look at the level that you're asking the question, and I think the concept of personal responsibility is alive and well, no matter how deterministic you might come to think the brain actually is in its operations. Because you are, the decision-making process can follow the rules, and those rules are based on the knowledge you've accumulated over the course of your life and so forth and so on. So the rules are in the social group, they're not in a network in your brain.
But what if you're part of a okay, so let's take an extreme example. You're a kid growing up in Nazi Germany, and you are taught certain rules, and you carry those rules out, and then you end up at Nuremberg, and they're telling you that you committed a crime. Now, are you saying, Mike, that those were just the social rules of the group, and if you follow those rules, then there's no crime?
No. I mean the capacity to do A or B is going to be based on your past life experience, and that decision to act over, or make one course of action over another, is going to be the product of your life experience, and that whichever one wins is the result of your life experience, and that's how it works. And to say that, well, you're not free to do those, it's a meaningless concept. You're going to make that decision based on what you've experienced in your past. And now, whether you had a really rotten past and have a wacky belief system that is in tune with the rest of the culture, that's possible. It goes on all the time. But it's still, the system is able to make alternative choices, and the alternative choices are based on your prior experience. So it's kind of, you got to get, well, how does this system work? Well, it evaluates the history, your personal history, and decides that this is a good idea, that's a bad idea, and acts accordingly. So a lot of people don't like that, by the way. They don't like that concept. They want this magic, I freely chose. And there's a body of research that can help you explain why we so strongly believe that. I mean, you can talk about this determinism all you want, and give the scientific reasons and this, that, and the other thing, but none of us believe it, right? Come on. So why is that?
Well, yeah, I mean, when I was working on an article about the self, it was for Scientific American a couple years ago. It was really fascinating because it did sort of make you think about what good it is to have a sense of self, and I suppose in a way it could be good because it's sort of it's a kind of a good shorthand for understanding other people too. I mean, you just sort of say, okay, well, your brain basically treats itself, forgive the pun, and other people as these individuals, as these selves, as these eyes, and you can kind of organize everything around that. But
well, there's a fascinating bit of research that is being developed by a colleague here at Santa Barbara, Stan Klein, and others, and it looks at trait memory. Now, so while we're always interested in where our self is in the world, we're also very interested in the other person's self, right? Who is this guy I'm looking at right now, right? What's his deal? And so he's done this fascinating work where he has subjects in an experiment read a story about a person, Linda Jones, let's say, and the paragraph about her has all kinds of descriptions of what she's like and so forth. And it gets done with the paragraph, and an hour later you test the subjects, and they rank this person on a variety of personality traits that were apparent from the story. Okay, gets that profile. Then he brings the subjects back 6 months later, a year later, and he asks them, well, what about that Linda Jones? Who? Linda Jones. You remember that story? No, I don't remember that story. And then you say, okay, listen, would you just fill out this chart about what this person might be like?
This person that the person you're talking to doesn't remember at all.
Right. The curves are superimposable. There's a 0.9 correlation higher. You remember the traits of that person, but you don't remember the faintest thing about the facts of the story. It's a very powerful phenomenon. And so, I don't know, I call it the reunion phenomenon. You go back to college after 35 years and you see somebody you haven't seen 35 years and you don't like them and you didn't like them then and you still like them.
Well, I guess that's actually that's kind of important in the courtroom too, because people form judgments about the person who's being tried, and that's right. Kind of a big part of it. Like, is this a good person? Is this a person who would be capable of doing this horrible thing? And I guess once you make that judgment, then that's going to really influence whether you decide someone's guilty or not.
No. That's in the teaching evaluation business in the university, they've now done studies that show that you expose students to 30 seconds of the teacher that's about to give the course, and you force them to give an evaluation of what they think about the course and the person, and you compare those judgments with evaluations you get after the poor professor has given 30 lectures. They're identical. So it's a very powerful mechanism that we have. We formulate our opinions so quickly. I guess in this campaign season, you wonder what that means.
Right.
What is going on in that case? I don't know. I have to think about that.
Yeah. And people just sort of size up the candidates pretty quickly, and then that's about that. And it's pretty hard to sway them after that, maybe. Well, actually, talking about the self and kind of raised something else for me, which is, we people change, and sometimes in kind of profound ways. I guess the most extreme cases I've read about are these lesion, brain lesion cases where people's personalities just go through these complete transformations. And I wonder, obviously, like we bring people to court after they've, allegedly committed a crime, but can we actually convict? Does it become an issue of convicting someone for a crime that they did when they were sort of a former self? They're not the person who committed the crime. How does that Is that all at all of an issue, do you think, or is there just enough of a continuity there that it's something that the courts don't have to worry about?
Well, it's a profound point, and I think right now, obviously, the courts can't deal with anything like that. I think the general populace has a hard time thinking about that issue. You've got to have that continuity, or it's just everything's moment to moment. We truly live in a virtual world, and the history doesn't count, and blah 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 blah. So and yet we know that. Again, you go back and dig out old folders of yourself when you're a young man, or a clip of film, and you look at that person. Who the hell's that? And of course, it's you. Except, and as you go through that life, and as you go through that time, of course, you never feel that you've changed. You completely are constantly adapting to your new physical state. I just came across some wonderful studies the other day about sleep deprivation, and so they examine physicians who have to stay up for 4 days in a row, which is the nature of their medical shift. The army guy that's in the field and so forth, and the person always says, "I'm fine. I'm ready to go. I'm fine." And then they do objective measures on their performance, and they're about 400% decrement in their skill. And so we constantly, even though we're diminishing with age, we think we're hot stuff, at all times.
Well, then,
which certainly leads to a certain amount of happiness. So it's not all
right. Well, then there's the issue on kind of the other end of the spectrum. The follies of youth. I mean, I guess traditionally, people have not been held accountable for their actions to some degree. So we had a little more technical trouble. These Macs that we're using have this weird way of making you think they went to sleep when actually they're recording away. So I think we've got it figured out. And so what I was talking about was the folly of youth, which I'm thinking about how the courts look differently on crimes committed by people who are under 18. Not that any neuroscientist decided that 18 years was the magic cutoff. And actually, it's interesting how recently, Mike, you can talk about this much better than I can, about how the prefrontal cortex, the front of the brain where a lot of the sort of higher thought and decision-making takes place, it keeps maturing until people are like 25 or something?
Yeah, maybe even longer. I'm still counting on some connections to occur.
Oh yeah, you're a work in progress. Well, that's good to know.
But no, it's a very major thing in adolescence that simply the connections aren't fully formed, and it's also difficult what you do with that information too, because at one level their rule behavior is certainly known, appreciation of right and wrong is certainly intact. So it may come down to kind of issues like just impulsivity and other kinds of biasing towards doing things that are just ill-advised, being more susceptible to social group pressures. I don't know. It's one of the topics that we're going to examine, and it's easy to say, the brains are differing because they're not fully developed yet, and that's true. And but what does that mean, and how do we want to deal with that information? That will be a topic of one of our networks.
Just to speculate, would it be possible to have a teenager do some type of cognitive test to see how capable they are of making decisions that are connected with whatever they're being accused of, or is that not possible?
Don't know. It seems utterly reasonable. There's this, I mentioned it earlier, there's this big chasm between understanding something cognitively, right and wrong, and appreciating it. Mm-hmm. So all kinds of people, this goes on in the extreme cases of psychopathy, that they very frequently can tell you that something is wrong. But then you dig deeper, and yet there's just no appreciation of that. They can't appreciate it. They don't feel it. Or there's some other secondary process there that is very importantly going on and awry. And whether that kind of full appreciation and implication of something is one speaks of immaturity and so forth, is a factor or not. I think it has to be examined, and where that goes, it would be way too soon to say. In terms of really looking at this in the legal setting that we're talking about here.
Right. I mean, it's. I wonder. Do you think that as neuroscience sort of makes its way more and more into the law, that there's going to be more of an attempt to have sort of neuroscience-based treatments for people who are found guilty of crimes? I mean, if it turns out that you have an underactive amygdala, and this has something to do with a crime you committed, would courts be like mandating that you take some kind of therapy for that? I mean, obviously these therapies don't exist yet, but I'm just trying to think down the line.
Well, such interventions would be, I'm sure, highly controversial. In some sense, such things are available now in terms of sexual offenders. There's all kinds of probably hormonal manipulations you could do if you wanted to. And we went through that years ago, and it just didn't take. And so now with sophisticated neuroscience being able to change maybe neurologic states that would be supposedly beneficial to getting a person up to the norm, I can see a lot of people resisting that, even with the technology present. So, first of all, we're not theirs, except as we are in psychoactive drugs and that kind of thing. But in terms of actual manipulating the material mass, the neurons through stimulation and that kind of thing, it will be that would be a vigorous debate if someone came up with something that worked as to whether it should be applied or not. And I think a welcome debate. I don't know where I am on it right now, but I know enough to know that that kind of intervention is a very difficult issue. There are data coming out now that there are effects on the brain from poverty. And I've read some of these papers. It's fascinating. Yeah, that, I mean, in a sense, like growing up poor is kind of almost like this, like a neurotoxin. Right. And that right now is an explosive topic. I've heard people say, so now on the backs of the poor, you're going to put the fact that their brain isn't quite right. That's horrible. And so there's that view. The other view, the way the neuroscientists think about it is, okay, we're defining a problem here. Now let's go see if we can have some interventions to cure it, to help it, and not worry. It does. I mean, it's interesting that this does. It feel There's something it has a weird feeling reading about this stuff, and it's hard to know what to think of it. And yet, I mean, everybody knows that poverty is linked to all sorts of diseases, to all sorts of diseases of the quote unquote body as opposed to the mind. And I mean, at least when I think about that, I think, well, okay, that means that we have to do more to deal with poverty to alleviate these diseases. But then when you start talking about effects on the brain, in a sense, you're getting to people's cells, and it's the cyborg problem too.
I'm sorry, it's the what?
The cyborg. it's okay to have somatic assistance, new knees, new hips, new this, that kind of thing. I think when you start talking about artifacts to be assistance to the mind, people don't like that at all. I mean, don't touch my brain. Don't touch, because that's myself and so forth. So yeah. But I don't know. My view is that these things are so young in human history that as people think about them, they'll start to think about it differently. And I just don't know where it'll go. I mean, there's a lot of I sit on the president's bioethics council, and there's a good representation of people there who just find all these ideas abhorrent, that you're messing with the human condition, and or you will be. I mean, they're trying to think ahead, and that's not a good thing. And so we'll have to see where it all goes.
Well, I recall, like in your books and such, and that you take a pretty sanguine view of these kind of treatments compared to some of these people who say that anything that alters our minds is tampering with our human nature. Would that be fair to say? That
Yeah, I'm all for AIDS. AIDS, not AIDS.
Right. I got you. But if I've got two little kids. When they get older, if they say, "Well, Dad, I need this. I need these pills that are going to, enhance my interior cingulate because I'm going to take the SATs tomorrow." I don't know. I do feel like that's wrong. Whereas if they said, "I'm just going to, I'm going to have a cup of coffee before I go in there," I'd say, "Yeah, okay."
Yeah.
So do you think we're just going to get used to it? We're just going to be like, okay, well, I'm going to take this drug that's going to keep me awake for 4 days because that's what I got to do, and now I'm going to take this because I don't know, I need to, do something else. Is this just going to become part of the environment and that's it? Well,
let's start with the easy ones. Anybody listening to this over 60 or 50 even, if they were offered this little pill that finds you accessing proper names with ease like you used to be able to do, would you say, well, just throw that right in there with the Lipitor and the other stuff you take, because I'm all for it. And so, okay, there's a mental manipulation, and people are working on that. They may be getting close to it, and so now, okay, so we're cranking up the memory. Now, what about the sleep wakefulness cycle? Another huge issue, in life. And well, we've got this new pill. It's got this brings a systematicity to sleep wakefulness cycle. You take that, and you go to sleep when you want to, and you wake up.
Right.
Give me one of those too. That's great. And now you see how quickly you get into the balance. So the memory pill, you want it to be of a particular kind, because probably what you don't want it to be is something that creates utterly vivid memories of your everyday experience.
So what would be wrong with that?
Who wants them?
Because I guess a lot of memory is basically forgetting. It's actually like cutting away.
Yeah, look, you want to take the best of the day and maybe ruminate about that, but 90% of it is dealing with stuff that is utterly boring and routine and frequently obnoxious. And if you just were a tape recorder and it just kept replaying in your mind, it sounds just like horrible. Yeah. So anyway, so can the pill be selective to just say, okay, it's Carl Zimmer I'm talking to. Who am I talking to? The kind of stuff. So it's anyway. It's just an example that there are some things that will be easily welcomed, and there are some things and then the double use and misuse of that is then your child sneaks into your medicine cabinet for his SAT and pops it. Is that fair? And
the issue of fairness.
So that's the reason why somatic drugs and physical enhancement are so widely frowned upon, because it's basically cheating. And our species doesn't like cheaters.
Right.
So and in a sense, if I can recall proper names for it, I'm cheating Mother Nature here, but no one cares about that. We spend half our life trying to cheat her. So.
Right. Well, the problem I think in that I've certainly heard that kind of line of argument before, and the problem I think with that is that people aren't thinking that when people see a pill, they think molecules, they think biology, they think something directly acting on the brain. So they understand the connection there. But so if you were to take some cognitive enhancing drug before you go to take the SATs, people would say that's cheating. But what about taking like one of these prep courses? Your parents bring thousands of dollars beyond your regular education to send you to this place. Now, I mean, obviously, your brain has to be changing when you're sitting there. I mean, that's part of life, and so I don't. The cheating thing doesn't. It's more. I don't dismiss it, but it's more complicated because I think that people just like to pretend that there's this whole range of experience that has nothing to do with the brain, and then just if there's a pill involved, well, that's dealing with the brain.
Well, you're absolutely right. I use that very example in the ethical brain. And what's the difference between these two things? And it's really hard to chase down and be offended by one and not by the other. It's interesting. I've talked to statisticians who say that these little changes in people who might cheat and use a pill, or people who do take the Kaplans, to have them actually budge the mean of the SAT is because so many people take it is very hard. So it may individually pop up their score, but there's some new experiments that out too, that are new observations out that it may not be doing that much actually.
Oh, really?
Yeah, the course of the time between the two tests covers for a lot of the variance. I'm sure that's argued about quite a bit, and I don't have first-hand data, so I shouldn't be talking about it. But yes, if you change it through behavioral training, or you change it through the quick method through a pill, basically talking about the same thing.
Now, another way to change behavior is addiction, and I guess that's another thing that you're dealing with.
Yes, the third network based in the East Coast is heavily into that. Yeah.
So, I mean, are there any? Well, let me just sort of ask, like, when neuroscientists look at addiction, I mean, what are some of the key things that they've figured out? I mean, there's been so much research using brain imaging and other things to figure out what's happening in the addicted brain. I mean, what do you think is important for people to understand about what happens when people get addicted?
I'm going to punt on that because it's a. I mean, there's a bunch of stories about vulnerability and there's a tremendous amount of knowledge about addiction and the brain, and the question is exactly what you said. How is that going to apply in this law setting? Who's going to come in? Is neuroscience going to come in and say we can deal with that draw towards addiction and neutralize it, and as a result have a tremendous effect on rehab? And if we had that kind of effect of rehab, should we just eliminate the sense of blame that comes when an addict in the pursuit of seeking their drugs commits a crime? Those are all very central questions to, and this group is going to work on them. And so I would like to just leave it that on that particular point that that's one of the things you're going to be hearing about from this project. I don't want to preempt them anyway.
Oh, no, I don't mean, certainly don't mean to do that.
Yeah.
Well, I guess, we're almost done with the hour, but I may want to kind of step away from the law for a second, just because, I mean, I just find cognitive neuroscience such a fascinating area in so many ways, and the research that comes out is so cool. Just to throw an example, your own research on people with split brains. I mean, it just seems to keep continuing. Actually, I should stop for a second. Could you? So some people watching this may not be familiar with the research program that you started with split brain patients. Could you just tell people a bit about that?
Sure. So this was started 45 years ago at Caltech with my mentor Roger Sperry and my friend and colleague Joe Bogan. And what we were doing, we're studying patients who had their hemispheres separated in an effort to control their epilepsy. And so the big connection between the two hemispheres is something called corpus callosum, and the surgeons would cut that. And the idea was that if a seizure started in one side, it would be isolated to that side, and the other hemisphere would remain seizure-free, and as a result, there wouldn't be a generalized convulsion. That was the idea. And I was part of a team that said, okay, look, what are these separated hemispheres like? How is the left hemisphere different than the right? And it turns out there are huge differences between the hemispheres, and we discovered particular mechanisms localized to each hemisphere and the like. And so quick shorthand is for most people, your left dominant hemisphere remains the language hypothesis generating hemisphere of life, and the right hemisphere is very good at the apprehension of many, many kinds of perceptual stuff and so forth. So a long and rich story, and what it really does is it ties you very closely to the notion that the brain underlies all kinds of things that we hold dear with respect to our conscious experience, and it certainly does, and that's what the field of cognitive neuroscience is trying to pursue and really understand that stuff.
Well, I mean, I still hear people talking about, oh, I'm a real right brain person, or I'm a real left brain person. That seemed like a trend that really kicked in the 70s.
Yeah.
I mean, does that have any validity?
No.
When people talk about that?
No. It's an oversimplification. People will, if they think if they're highly analytic and verbal, that they're all left hemisphere, and people who paint or people who do some other sort of performance have another capacity, and it maybe located in another part of the brain. And they just use the left brain, right brain as a quick shorthand for that. So the story sort of got built up. But there's probably no question that there are different parts of the brain active when you're being highly verbal and analytic versus giving perspective to a visual scene or even an auditory scene, as in music. And different circuits are involved and everything, but you probably shouldn't think of them in terms of left brain, right brain, but just as differing circuits that are active. So anyway, that ties into some interesting other questions about the role of education and the arts in maybe having enhancing effects on cognition. And there's these well-known correlations on that point, that kids who take music lessons and art lessons and drama lessons and so forth tend to do better in school. And why is that? Is that just correlational, or is there a real effect there? By mastering one, you're having a facilitatory effect on the other. And that, I've just put a note on that. managed a little project for the Dana Foundation on that, and we're actually reporting that out in a week or so, whenever it is, in Washington. And there's some very interesting phenomena that came out of that.
So, is the split brain research still continuing?
Oh, yeah. Yeah. No, its heyday has passed, for sure, because most medications, most surgeries are not done now. They're treated by medications. But and so, for example, my own research program is because of the advances of brain imaging, and in particular because of the advances of something called diffuser tensor imaging. What we want to do is study the normal brain and see how it's hooked up, how it varies from person to person. What are the nature of the connections? And you do that by putting people in MR scanners that don't have the surgery. So your normal college undergraduate then becomes your subject. And using that, we find all kinds of very interesting things about individual variation and how your brain may have different patterns of responsivity as opposed to mine and so forth. So that's where we are now, and it's very interesting work, I think.
Yeah, it's this diffusion tensor imaging. I mean, I don't think many people know about it. I mean, it's really...
That's brand new, basically.
Startling. I mean, fMRI works by measuring... essentially, in a sense, measuring the flow of blood in the brain, which can kind of be kind of a proxy for what parts of the brain are becoming active. And this diffusion tensor imaging, I guess I'm not 100% clear on the technology that makes it work, but I mean, what it does, the outcome is that you can see these connections, these between different regions of these brains, sort of the cabling system of the brain, as it were.
That's right.
So is this stuff really starting to really kind of become useful? It seemed like it was pretty experimental, pretty early stages until recently.
It's a very new in the last 2 or 3 or 4 years, but in terms of it's really coming on the scene in the last couple of years, and it's the first time really that what you can call long tract anatomy. So these large neurons that communicate between various parts of the brain, the front, the back, the left, the right. Those have never really been studied before in the human brain because you just can't get at them. And so now with this imaging technique, you can study in vivo, which is to say the living person, their variations in connections. And it basically capitalizes on a technique that measures the ease of flow of water down the neurons, and the anotropic properties of the water in the neuron. And the physicists come along and others and in very clever ways figure out how they can use that to follow the tracks of the brain. So it's brand spanking new, and lots of people working on it, lots of great work. Oxford, Stanford, we're doing it, but there are really a lot of major efforts being made, and it's an important work.
I mean, it seems interesting to me from a historical perspective because, I mean, neuroscience has always been kind of saddled with this image of being phrenology, the sort of 19th century idea that there are these little patches of your brain where some particular trait was, I don't know, I'm trying to remember what language or
math,
ability or
math, art,
right,
spatial abilities, and the early days of brain imaging, people were criticizing it because it was sort of neo-phrenology. They said, this part activates when you do language, this part's when you're listening to music, this part, blah, 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 blah. And what it is those are tracers of mental phenomenon that will be more fully understood when more imaging data comes in. Because what they'll do is they'll start building models of the variations in activation patterns associated with particular cognitive acts, and those models will become more and more accurate as to capturing what you actually are thinking about at a particular moment in time.
Right. I mean, in a sense, it's more the network than some particular
Absolutely.
little chunk of the brain.
Right.
I mean,
Right.
I don't know. It seems like a general kind of trend in at least in biology. I mean, when I've written about people who study like cell biology or genetics, they're much more interested now in networks than in single genes or single proteins. I mean, that there are these things that come out of. You have to understand how the whole network is working as opposed to just breaking it down to the individual pieces.
Yeah, absolutely. I mean, that's the story. That's the hunt. And there's so many deep problems, that trying to really draw causal links between molecular cellular mechanism and the systems level, the neurons all hooking up, and then cognition, and then how cognition interacts with the social world. How do you really think about the exchange of information between those levels? What constitutes an explanation at one? What is the meaning of that explanation at the next level? Et cetera, et cetera, et cetera. These are profoundly difficult problems, and yet that's I think that's where the meat is in this century, is to really try to think about that stuff.
Well, that's probably a good note to end on.
Good.
So thanks so much. I mean, this has been great, and thanks for soldiering through the technical difficulties, but I think it's been worth it.
Great. Thanks, Carl.
Okay, take care.
Yeah. Bye.